48 miles an hour.
We all know that it needs how many gigawatts?
Yeah.
So, all right, so let's look at a couple things here. Let's say we got 3 students that are measuring the length of this block. Real exciting. So here's what we get. Student 1 gets these 2 measurements. Student 2 gets these 2 measurements. Student 3 gets those 2 measurements. All right. So let's say, how could we describe? There's some variability there, right?
Yeah.
So how could we summarize maybe both of the first 2 measurements? How could we summarize that in a single number? So say it again. So yeah, okay, I could average it, couldn't I? Right. I could say something like 18.8 centimeters, but I also want to communicate that that wasn't my actual measurement, right? I measured something different from that, and there was some variation. So what could I do? I could say approximately. And maybe I even want to communicate how much variability there was in the measurements. Oh, okay, so something like plus or minus, what's that going to be, 0.03? Or 0.3, I guess?
Yeah, this is just for the first 2 students.
Yeah, for the first 2, right. Okay, how about for the second 2?
Wait, are we still doing? That was just for the first student.
That was just for the, for the first student, right.
Oh.
Yeah, first 2 measurements, first student. Okay, student number 2. So we're going to give what, 19.0 centimeters plus or minus 0.2 centimeters. And for student number 3,
18.3.
This one, the average would be 19.
Oh, that's the same measure. Okay.
Okay. And then now we're going to average these 2. So 18.3 centimeters plus or minus 0.1 centimeter. Okay. All right, so when we want to talk about measurement, there's two different terms that come up a lot, okay, that are important to us. One of them is precision. Okay, so precision describes the degree of exactness of a measurement. So which of these 3 measurements was the most precise? Student 3 was, yeah, because the variation was smaller, right? Does that make sense? Student 3's measurements were more exact because they were closer together, okay? There's another part that comes into play here, though. Does that necessarily mean they were the best? Well, not necessarily. They were the most consistent, but they might have been the most consistently bad, too. We don't know, right? Yeah, so we got to know what is the actual length. Let's just say the actual length is 19.0 centimeters, right? So then probably who wins? Student 2 does. Yeah, right. Student 3 in that case was way off. What is the term that we use or the word we use to describe why, how close? Yeah, okay, accuracy, right? Accuracy is what's describing how well a measurement agrees with the standard or the accepted value, right? And those are different things, precision and accuracy. And they're commonly mixed up. Okay. This will be, when we get in the lab, this will be really a more important thing, okay? All right, so I think that was all. Yeah, let's flip it. Okay, so also when we're taking measurements, related to that last issue we were just dealing with, we have to know a way to describe how many digits are significant or meaningful in our measurements, right? And so we're gonna come up with some rules, and you've done this before, right? Probably in chemistry, I think you would have done this. Yeah. Okay, so let's just review a little bit then. How many sig figs are there in this?
3.
So we get 3 there, don't we? How about here? 3. Is it 2 or 3?
3.
Okay, good. It's 3 because when we have a 0.0, that's implying that that 0 is meaningful. It just happens to be the digit 0, but it might have been 1 or 2 or something, right? Okay, so that's also 3. How about this guy? 3. How about this guy? 4. Okay, so the leading zeros are just placeholders, right? Okay. How about this one?
2.
Okay, I'll accept 2, but what's another answer? Maybe 4. I mean, maybe, we don't know. How come?
Because they didn't put the period.
Okay, because we don't really know where the significant digits stop there, right? It could be, maybe this has been, for example, rounded to the 100th spot, or maybe it we just got lucky, and we're actually measuring to the nearest digit, but it just happens to be 8100. Yes.
Would we assume 2 since they didn't put a decimal in, or?
Okay, yeah. So for the purposes of the calculations we're going to make, we would assume 2 on this. Yeah.
Please excuse this interruption. Blanca Alvarez to the office, please. Blanca Alvarez to the office.
Okay, and I don't want to get too hung up on this. I think sometimes we make a bigger deal out of this. Now, I don't want you worrying about significant digits to get in the way of you, like later on, learning how to understand, how to do the physics, because really that's way more important. But this is something you got to be aware of. It's, I will throw this in on problems sometimes, and so you just got to be aware of it. What would be a way to avoid any uncertainty with writing this number? Okay, we could do that. So if we were to, for example, put a decimal right there, I can see where maybe that would indicate it's 4, right? Okay, now I don't have the ability, and I've tried, when I do all my programming in Moodle, I can't do that reliably. And so, yeah, that would work, but I'm not going to do that. I actually have never done that ever. I mean, that's not, I've taken a lot of physics classes, and that's never been something we've ever really worried about. Yep.
Scientific notation.
Okay. Yeah, what we could do, though, is we could turn this into scientific notation, right? And then we would know. If I wrote this in terms of scientific notation, what are the 3 possible outcomes?
8.1.
Okay, 8.1 times 10 to the 3rd, I think, right? Okay. Or 8 point, right? Or, and scientific notation solves that. It really solves the problem, right? If we use scientific I'm not saying we always will, because it's inconvenient. It's harder to write, with only 4 digits, it's harder to write this in scientific notation than it is to just write the number, right? But it does alleviate that issue, right? If we use scientific notation, we always know how many sig figs there are. So what are our rules then? Sounds like you are pretty familiar with these rules, not a big deal. That look familiar? So can we agree that all non-zero digits are always significant, right? All final zeros after the decimal point are significant, right? So for example, I didn't give you one like this, but what if we did something like, this? How about 0.13200? How many sig figs are there? There are 5, yeah. Okay, make sense? And so we got that. Zeros between other significant digits are obviously significant, right? If I've got a 0 that's pinched between a 3 and a 7 or something, right, then we know that's significant. Zeros used solely as placeholders are not significant, okay? So you got that stuff, I'm sure. All right, so arithmetic with significant digits. Now, one thing I'll tell you for sure, too, that this doesn't really, the physics book doesn't mention this, but this is done incorrectly so often that we got to talk about this. When you're doing a string of calculations, let's say you're doing a major calculation, when do you round? So let's say, for example, I've got several different measurements with differing numbers of sig figs, and I'm going to do a big calculation with them. or we're gonna ultimately gonna round our answer, maybe it's just a purely mathematical case, and we're gonna round our answer to the nearest 100. What do you think?
We would round to the amount of significant figures that the one with the least amount of significant figures had.
Right, and you don't do it until the end, you round once, right? Otherwise, you accumulate rounding error. So if we're even just doing a calculation, and let's say we wanna round our answer to the nearest 100th, and we're doing a bunch of calculations with maybe some irrational numbers, pi, some square roots and things. There's a tendency to think, okay, well, we're gonna round our answer to the nearest 100th. Why don't we just round throughout the process, just kind of maybe make the number smaller to right or something. Why don't we just round partway through the process? Do you see that's gonna have an impact on the answer though? Yeah. So you don't wanna do that. You wanna only round once at the end. And as a consequence, I wanna kind of help train you to do calculations on your calculator exclusively. So as much as possible, you don't want to be doing a calculation and writing a number down and doing another. You don't really ever have to write anything. If you get really good at using a calculator computationally, you can use the calculator to store numbers. You can do the calculation in a way where you can do it, crunch it all as one big calculation. See what I'm saying? And then you just hit enter one time. Get an answer, which you then can round if you need to. Okay, and you'll see what I mean as we go through we start getting into doing more problems. We'll talk about that some more. But hold that in your mind a little bit. So arithmetic with significant digits. When you're adding or subtracting measurements, what you do is you're going to perform the operation. Add or subtract the list of things, measurements, and then you're going to round the result to correspond with the least precise term. So this really doesn't have anything to do with the number of sig figs this time, right? You might have, you see what I'm saying with that? Let's look at an example. What if we have something like, let's say we're gonna find the sum of these measurements. 1.2345, and when we're adding things up, we'd like to add them up so the decimal points line up, right? Does that make sense? So how about 3,421.0001 5,000.27 and 0.17. Okay, what would I do? What's the number with the least number of sig figs? The bottom one has 2, right? If I add all these up here, let's see, what do I get? 6, 4, 17, so what's that? 6, 2, 84. So how far back do I go? Yeah, okay. Here are these two measurements, each are the least precise. They only go out to the hundredths place, right? So I've got to round everything off to that place then. Being as this number is a 4, the next digit is a 4, we just keep that 7 and that's our answer. Make sense? Okay, so that's adding or subtracting, right? Now multiplication is different. Scott already told us how to do that. With multiplication, we're going to perform the calculation and then we're just going to round the result to the smallest number of acceptable sig figs, right? Of all the factors that were part of that calculation, right? So if we're, for example, I think you probably understand this just fine, but let's look at one quick one. What if we want to multiply 3.2 times 1.77 times 31.01? How many sig figs are, we can multiply all those out on our calculator, get an answer, but how many sig figs can we keep? 2, that's it. Right, we gotta round that back to 2 sig figs. Okay, make sense? All right, I'm done. That's it. Grab a Chromebook, get working.
Okay.